Hello and welcome to this session where I'll take us through the GeoStage platform. Our company name was originally HydroBlue, and our focus is on applying machine learning and data science to geospatial problems, especially in the area of access to water. Our machine learning model can predict the location for borehole drilling to an accuracy of more than 3 times that of existing methods. The innovation has been recognized in various awards in recent times, as you see in this list. As we realized that the service could be applied in several other areas, it evolved to become a platform, which we call GeoStage. I'll mention some of the other applications later. Here's the original problem statement. We still have today 2 billion people consuming contaminated water. The cost of drilling a borehole is 100,000 Rand, even though the accuracy of the site yielding a good borehole is only 25%. Just in South Africa, there are 12,000 non-functional boreholes, representing a loss of almost R1 billion. The interest in our case is to increase the accuracy when identifying a good borehole location. This figure illustrates our process for creating a machine learning model. First, we have a data set of over 5,000 boreholes showing good and bad boreholes. We also have the coordinates of these boreholes. We then connect with a GIS imaging service, such as the Google Earth Engine or the NASA dataset and others. We can then join the geocharacteristics like rainfall, vegetation level, surface temperature, and so on, using the coordinates. We now have a data set from which we can develop a machine learning model. We use several learning algorithms, including nearest neighbors, support vector machines, decision trees, naive Bayes, and so on. We can also use boosting to get an overall accuracy of about 80%. The user sees none of this complexity. They simply drag the map to a geolocation that they want to investigate and click on Evaluate. This is, of course, generally a point that was not in our original data set. In the background, our service consults with the GIS services and looks up the geocharacteristics of that location. That will give us the data we need to run the model and predict the effectiveness of a borehole at that geolocation. When comparing our predictions with other services, we find that most existing approaches only work in a narrow range of environments and requires special equipment, which disturbs the environment. As mentioned earlier, these methods are also more than 3 times less accurate than our service. Here's the value proposition. For drilling just 700 boreholes at a cost of 100,000 Rand per borehole and applying our improved accuracy, we would reduce the loss rate by 35 million Rand. This is a saving of 50% over the existing methods. At just a 10% service fee and conservatively estimating only 2% penetration of the market, our company would be profitable at over 5 million Rand per annum. We are fortunate to be supported by these investors, in particular the Water Research Commission, the Technology Innovation Agency and Smart Exchange, and Umgeni Water. Our infrastructure and machine learning is supported by the Modern Scholarship Organization, and we use AWS servers and other services for the actual GIS. Here's the project team. In addition to GIS and machine learning, we also have staff with microbiology, hydrogeology, and product design experience. We are in the process of developing coursework for others to be able to develop geospatial applications and implement machine learning models effectively. The platform makes it easy to manage your own data sets, to connect with geo features and GIS services, and to build and deploy machine learning services. Here are some other applications built on GeoStage. In the GeoTrace service, we can track any device, including cell phones, just by visiting our website. The service gives a driver feedback about their fuel efficiency and safety characteristics. This has applications in fleet management and the insurance industry. In the AgriPlanner service, we identify suitable locations for specific crop types. We also determine the optimal times for planting and harvesting. In Impact Intel, we can predict the likely influence of any building or engineering activity at a geolocation. Thanks kindly for listening.